So which pretty much is like a wider look at the different techniques. Okay. The first and the most important thing is we need to learn basic integrations. If you remember, I gave you a list of 20 most common integrals, and then I gave you a much more comprehensive reference list with 1 page of derivatives and 7 pages of integrals. Remember that? I gave you, was it last time? So we need to remember, let me give you the last 6 integration formulas. Okay, so the first strategy will be learn the 20 basic integration formulas. Okay, I'll give you the last 6. Okay, so we have the integral of the tangent, the integral of the cotangent. Do you remember those? The integral of the tangent is the natural log of the secant. The integral of the cotangent is the natural log of the sine. Okay, the next one, how about the integral of dx over x squared plus a squared? If it was x squared plus 1, it would be what? The inverse tangent, right? So here we have a, so if we write a squared times x over a squared plus 1, if we factor out the a squared, then we end up having a little substitution. The result of this integral will be 1 over a, the inverse tangent of x over a. So this is a little bit of generalization. I'm sorry? No. We have a square root. We have x squared, so there is no square root here. Oh, the denominator, there is no square root. If it was a square root, then we use trig substitution. All right, let's look at the next important integral. Will be the integral of dx over, this time we're going to have the square root of a squared minus x squared. Because x squared cannot be greater than a, the obvious choice will be the sine substitution, right? Or x equal a sine a, and the result will be the inverse sine of x over a plus c. So this is a trig substitution. We have another substitution. Is the integral, and this is the result of partial fraction. We talked about it earlier today. Dx over x squared minus a squared, no square roots, and we factor x squared minus a squared as x minus a times x plus a, and we differentiate, and the result, the general result will be 1 over 2a, the natural log of x minus a over x plus a. Matter of fact, you can see it right here on the other side of the page. Okay. So, plus c. And so this is by partial fraction. and the next one will be the integral of dx over the square root of x squared plus or minus a squared, like so. Here we can use trig substitution. We end up having the natural log of the absolute value of x plus the square root of x squared plus or minus a squared plus c. How we obtain that? Well, this can be either the secant or the tangent. Okay, and then we work it out in reverse, and we end up having these results. So this will be the first strategy. The second strategy will be to simplify the integrand when possible. To give you quick examples, for instance, the integral of the square root of x times 1 plus the square root of x dx, you can simplify it as the integral of the square root of x plus x dx. And now this is easy. If you have the tangent theta d theta over the secant squared d theta, then you simplify it. Remember, secant squared is 1 over the cosine squared, and the tangent is secant is sine over cosine. So you end up having the integral of the sine of theta cosine theta d theta. Well, this is half of sine of 2 theta, right? I think you have something like that in the homework. The next simplification, what happens if you have the integral of sine plus cosine, but everything is squared? Okay? So what happens is, if you think about it, you have sine squared plus 2 sine cosine plus cosine squared. Well, sine squared plus cosine squared is 1. And 2 sine cosine is sine of 2 theta. So you end up having 1 plus the integral of sine 2 theta d theta. So that's quite a simplification here. Okay. I'll do one more strategy and I'll stop. What time is it now? Yeah, I have. So the next strategy will be to look for obvious substitution. Look for a simple substitution. For instance, a common substitution that I use several times today will be actually the substitution of the form when you have u equal a function g of x and du equals g prime of x dx. Okay, example will be the integral of x dx over x squared plus 1 dx. I think I used it today twice or 3 times. Okay, u equal x squared plus 1 and du equals 2x dx, so therefore dx x dx equals 1/2 du. And we used it many times. Okay, and next to last, and I just give you the title, but I'll give you the breakdown on Thursday. We want to classify, no, I still have a little time, the integrand according to its form. For example, I can, if I see product of sine times cosine, then I know what to do. if I see product of tangent and secant, I see product of cotangent and cosecant, right? That's one group. If I see rational function, then I'll do partial fractions, right? If I'll see something we just touched on, the nth root of ax plus b, what I'll do is I'll rationalize or rationalized substitution. Such as u equals the nth root of ax plus b. And I'll finish this particular strategy by, if we have product of a power function or polynomial times transcendental will be something like trig or log or exponential function. Those are transcendental. Then we integrate by parts. To give you an example, if we have the integral of x squared minus 1, which is a polynomial, times e to the 2x, which is transcendental, or the integral of x times cotangent of x. Again, cotangent of x is transcendental. Then we integrate by part. Okay?